Yeah, hello everyone. Myself Maruti. Welcome you all to the math video session. In this video, I have taken a sum from trigonometry. So instead of dealing in a straight way, generally I have the habit of dealing in a logical way. From where to start, why to start from there, how to reach the answer. That's what we are going to discuss in this video. In this video, I'm going to explain the sum. Show that 1 minus tan square a by cot square a minus 1 is equal to tan square a. This is the given question for you. We have to start here and we have to reach here. If you check it out, in the question, we are having tan square, and also we are having cot square. Okay, in the question we are having tan square and cot square. Now, in the answer, what do you have? Where you have to reach from the question to answer? In the answer, everything is in terms of tan square. Okay, these are present. These are the two trig ratios which are present in the question, and this is the only trig ratio present in the answer. Fine, fine. But general thing is, whenever you see powers in the question, we have to go for the square identities. Like first square identity, sine square theta plus cos square theta is equal to 1. Right, secant square theta minus tan square theta is equal to 1. Cosecant square theta minus cot square theta is equal to 1. Whenever you see powers in terms of squares or power 4, power 8, we have to use the square identity. It's better, it's good, it's easy way. But in this sum, right, the question is in terms of tan squares and cot squares, and we are reaching tan square. Okay. If we use square identity, from tan square we reach secant square. From secant square again we have to come back to tan square. If you go for cot square, if you use a square identity from cot square, we have to go to cosecant square. Then again we have to come back to tan square. It is a little bit of far distance. Therefore, what I am choosing means, right, both of them we are, first I am taking them tan square and cot square to the quotient identity. So we are having quotient identities. Right, we are having quotient identity. From tan square I am going back, I am taking little bit back step. From tan square I am going to the quotient identity. From cot square I am going to the quotient identity. You might be thinking, what's that quotient identity? You know that one. So tan is nothing but sine theta by cos theta is nothing but the quotient identity. Right, in the same way, cos theta by sine theta is nothing but cot square theta, that is nothing but the quotient identity. So I am taking a back step. From tan square I am going to the quotient identity. From cot square I am going to the quotient identity. Now if it is in terms of sine by cos, obviously it is nothing but tan. In the same way, cos by sine is nothing but cot, but we flip it. If you take the reciprocal, again we get back to the tan square. So this is my step. Instead of going from tan square and cot square directly to do using square identities, I am using, what is that? Quotient identity. You have to remember that one. So let's get back to this one. So given, what is given there? Right, that is 1 minus tan square a by, right, cot square a plus 1. This is what we are having. Okay, now what I am doing means, this is trigonometry. I am converting in terms of algebra. 1 minus, I like to write it as whole square by whole square minus 1. I like to introduce there. Now in the play, of course I like to write like this only, no issues for a while. Tan a and cot a. Right, so that, right, tan a I can write it as sine by cos, and cot a I can write it as cos by sine. Now I am writing it as 1 minus, in the place of tan I am taking it as sine a by cos a. Very good. Whole divided by, of course we are having square, again we are having square and minus, cot is nothing but cos a by sine a. Very good, I got it now. So now again I am bringing that power inside. I am bringing that power inside. I am using like 1 minus sine square a by cos square a. Very good. Very good. And here cos square a by sine square a. Very good. Minus 1. Okay. Now everything is in terms of sines and cos. right? Of course, we have to reach the answer tan square A. So as it is in terms of sines and cos, let me do one thing. Let me take the LCM. Numerator and denominator in between plus or minus. Obviously, we have to take LCM. Let's take the LCM here. Right, I'm keeping the smaller one. If there is no one at the bottom, it is nothing but 1 comma cos square. LCM is cos square A is the LCM. Right, in the same way the denominator, right, if there is no one, it is nothing but 1 sin square A and 1. What is the LCM of that one? Sin square A. Okay, I took the LCM for the numerator and also the denominator. Now 1 goes in cos square A, cos square A, cos square A into 1. I like to write it as cos square A. Okay, minus is there, minus. Cos square A goes in cos square, same goes in same one time. 1 into sin square A, I have written it as sin square A. Okay, now sin square goes in sin square, same goes in same one time. 1 into cos square A, it's nothing but cos square A, and we are having minus in between, minus. Now 1 goes in sin square A how many times? As this is, that is what it is, sin square A. Sin square into 1, sin square A. This is what we have got it. Now, if you check it out properly, the numerator is cos square A minus sin square A. Here also, cos square A minus sin square A. They are same. I'll be doing one thing. Straight away, I can't cancel it or I can't cancel it. Now, keep a bracket. Okay, now the entire stuff, what is there in the bracket, I am least bothered. The same thing is there. The total bracket became one stuff. Now I am cancelling this and I am cancelling this. You got it? Now, if I work on back, what is left over? It goes one time, it goes one time. So what is left over? 1 by, what is left over? It's nothing but cos square A whole divided by, let me keep this one straight, and 1 by sin square A, right? What is our ultimate target? Our target is to reach tan square A. Okay, so let's work on from there. Now 1 by cos square A is as usual, it is there, and I am flipping this one. 1 by cos square, if it goes to the numerator, it becomes sin square A by 1. Okay, you multiply the numerator and denominator, What will be getting? 1 into sin square A, it's sin square A by cos square A into 1, it's nothing but cos square A, which is nothing but sin square A by cos square A, as you all know, it's nothing but tan square A. So this is the given question and we have reached the answer. The simple logic is the same thing, right? The sin square A, I am not using square identity, those we have square. Right? I am using the quotient identities. What is tan? Sin by cos. What is cot? Cos by sin. I am using that. In the place of tan, I kept sin by cos. In the place of cot, I kept cos by sin. Now I pulled the power inside. I took LCM, but as I got the same stuff, I cancelled it. Left over, I have copied and I have reciprocated it. Now I got it as tan square A. This is the beautiful sum. The way of thinking from where to start, from to where to reach is the thing what you are supposed to do. In this channel, I have been placing both math and science videos.